Hey everyone, this is Joseph from StarDataEngineering.com. In this video, we are going to be looking at a batch-based data engineering project that is aimed at beginners or people who want to transition into the data engineering industry or career path. And I get this question a lot from my subscribers and some of my colleagues and friends, especially from people, as I said, wanting to move into the data engineering industry. They want a project that is that gives them the experience they would require for their job, such as working with industry standard OLAP databases such as Redshift, Spark, using EMR, which is very common, and using an orchestration software tool like Apache Airflow, all of which we will be using in this project. So let's get into it. What is the objective of the project? So we are assuming that we are working for a user behavior analytics company, and they collect user data from different data sources. It's a common pattern where companies either pay third-party data providers or collect their own data. So we are trying to emulate that. And for this project, in order to keep it simple and constrained, we assume we have two data sources. One is a user purchase data, which contains user purchase details like what did they buy, how much did they buy, when did they buy it, at what price, etc., which we call as user purchase table right here. And then we have a movie review data set. So this movie review data set will contain the user ID and the review that they provided to a specific movie. And the objective is to combine these two and put them in a user behavior metric table in a OLAP database, which in our case is Redshift, which will contain the customer ID, the total amount spent, and the review score, which is number of positive reviews per date, and the review count and insert date. So basically, user behavior metric table is at a day level. So this has to run every day, this pipeline. Let's go into the engineering design part. So for our process, let's assume the movie review is a file which is dropped into your local file system. It's not the case in real projects. It's usually dropped in an S3 bucket or SFTP server somewhere, but we can assume that it's locally deposited into our local file system. And we are going to be pulling our user purchase table from a Postgres database. So let's look at the top part. Or actually, we can split this up into three sections. Right? The first section works with the user purchase data. Here, what we want to do is we want to pull the data from Postgres, get it into a table, get it into a CSV, which is uploaded to a S3 staging area, which is then loaded into a Redshift staging table. And in parallel, we can take a look at stage 2, which deals with loading the movie review dataset into a loading area using Spark to do text classification. So basically, we run a very naive Spark job, which does some text cleaning, and depending on the presence of a word good, it will identify a review as positive or not. This is extremely naive and does not work at all, but for the purposes of a project, it emulates a real life scenario. And once you have stage 1 and stage 2 complete, we can look at stage 3, in which we load the data in S3 into Redshift, and we do the join, and we get our user behavior table. So we can take a look at each stage at a time, but I will link the blog in the description below, and also the GitHub repo for the description in the description below if you'd like to follow it. So stage 1 is Postgres to file to S3, which is in the red box here. I don't think I'm going to walk through the code. Please look at the blog post if you want to follow through the code, or the GitHub repo. start with a starter branch if you want to try it out yourself. You can use the master branch if you just want the code and play with it. So let's take a look at step 2. Step 2, we get our file and then we put it in a S3 loading area, and then we do text classification using a Spark text classifier very naively, and put it in a staging area. Now you might be wondering why we are keeping the data in loading and staging area. This is a very common pattern that a lot of companies use, because there is always a scenario when the business comes back, their business or data science team wants to change the way data is processed, but they want it done historically. So they might say like, hey, we want to process these reviews in a different way starting 2 months ago. So if you had not kept the loading area, you would have to go back to the vendor to get all this data. So since you kept the loading area data, you can just directly use that to produce the staging, and you can rerun step 2 and step 3, and you will have your required data. So one of the key ideologies behind building a well-functioning data pipeline is that each of your tasks or function should be idempotent. What that means is, irrespective of anything else, for the given input, it will always produce the same output. So that will ensure that even if we have to reprocess a certain input, we can easily do that. And when we use Airflow, it's really easy to orchestrate it, and you can run parts of it, and you can do historic backfill or historic refill. So that's the entire project. As I mentioned before, if you like the code, please visit the blog. I put it in the description below, or use the GitHub repo, which I've also put in the description below. Now let's take a look at some design choices we made and what is wrong with those choices. So if you look at the first circle 1, which is pulling data from Postgres to a CSV, this is generally not a good idea, because Postgres databases or MySQL or any type of OLTP databases are usually used for app level functionality. So if you do a heavy pull on this database, it might lock the table that you are using for the app. So there will be huge slowdown of the app, which you do not want. What you want in a situation like this is to implement something like a trickle-down approach. So have either like every change you make via the app push to a Kafka queue and then be read from it, or you could use something called a Debezium, which captures each row level transaction change without impacting the database a lot. I have put a link to the Debezium tutorial below as well if you want to check that out. The other thing I want to note here is the circle number 2. So if you take a look at that in the code, you will see that it overrides the loading area and staging area each time. So every time you're basically just overwriting the same data over and over again. The problem with this, as I mentioned earlier, is that you cannot do backfill. So if you want to look at the data that was supplied to you 2 months back, you would have to then go to the data vendor to get that data. What you want to do is you want to store these files namespaced by the date in year, month, day format, so that retrieval is easier. And in our example, you will see that we have not written any unit tests or data quality checks, which is really, really important if you are doing a real project. So some next steps you could try to do if you're following the GitHub repo or the blog is you could do a data quality check after we have the user behavior table, and you can try to orchestrate this to run every hour instead of every day, which might be trickier. So it would be a good exercise to do that. So yeah, that's it. I hope this gives you a good idea of what a data engineering project would look like. And as always, if you have any questions or comments, leave them in the comment section below. I'll get back to you. Thank you.